Welcome to the Statistical Methods class. My name is Naoko Tsuboi. I'm going to be your instructor for the entirety for this summer course. As you will see throughout today's lecture, one of the most important messages is that if you want to succeed in this class, you must read the book and do the homework. Also, before moving on to the next topic, I would like to explain about lectures for this class. You will have different instructors per lecture. So sometimes it's going to be me, but many times it's going to be a different statistical methods instructor from UTEP. From the next slide, another instructor will explain today's lecture materials, and I will explain the details later on.
As you begin this course, you might be wondering, what are statistics really good for? And it turns out that this class is going to be one of the most important courses that you will be taking in your college education. I will give you a couple of reasons why statistics are important not only for your career, but also for your personal life. One thing that I know is absolutely true to everyone in this class is that taking this statistics course is going to meet a degree requirement that's going to help you to get closer to graduation. That's definitely an important benefit from taking this class. However, this class can benefit you in other ways, so we're going to talk about them. Statistics are important because it's going to help you understand research about people. It is true that the majority of students who take this class are majors in psychology, kinesiology, speech pathology, or some other area that works with human behavior or health sciences. If you are studying any of these topics, you are learning about people and about research that involves people. So you need statistics to understand this research so you can understand people better. Another reason why statistics are important is because they help us do research or understand research better. Some of you may already be part of a research lab, or some of you will be part of a research lab in the near future. This class is going to help you understand better the research that is going on in your lab. Furthermore, if you expect to go to a graduate school, more than likely, you're going to be conducting even more research. The skills that you get in this class are going to help you during those times as well, because again, it's going to help you understand research better. Statistics are also important for your graduate school education. Many of the graduate programs in behavioral and health sciences require some form of statistics because statistics are essential for research. Doing well in statistics will help you get into graduate school. And once you get into graduate school, statistics will help you succeed as a graduate student. Another reason why statistics are important is because of jobs, and I'm pretty sure this is something that could resonate to everyone in this room. This class is going to help you build some skills that are attractive to employers. For example, you will gain some experience with Excel. You will also learn to calculate and interpret basic statistics. Now, most people don't have these skills, and employers are looking for people who do. What you learn in this class can help you land good jobs in government positions or private businesses. These are examples of job openings right here in El Paso where employers needed people with statistical knowledge. There are similar ads for places all over the country. People with statistical skills are eminently hireable. I myself have been hired for jobs because of my statistical skills. For example, I wouldn't be able to teach this class if I didn't have at least some basic knowledge about statistics. Here's another reason why you need to understand statistics. You need to be knowledgeable consumers of the statistics when you seek information on the internet or read it in the news. To really understand information about health, mental health, jobs, finances, and consumer products, you need a background in basic statistics. If you want to understand and evaluate what your doctor tells you, you need statistics. If you want to select the best car or electronics, you need statistics. The world becomes much more understandable and you become a much more effective person once you can understand and evaluate the statistics you come across every day. If you have any interest in politics, you also need to understand statistics. Here are some of the big issues facing our country right now: global warming, income inequality, health insurance, immigration, and gun control. If you want to understand these issues and be able to discuss them intelligently, you need to understand statistics. Please go ahead and take a minute. I want you to write down the 3 most important reasons why you personally need statistics. First, write down these words: I need to learn statistics because, and then write down the 3 most important reasons why you need statistics and will benefit from this class. We have already discussed why statistics are important and how it can personally benefit you. I would now like us to shift our attention to discuss how to succeed in this class. Well, this course is largely self-directed, meaning that a lot of the things you will learn come from doing the readings and the homework problems. You need to set aside at least 9 to 12 hours per week outside of class for reading and homework. The key to success in this course is simple: read the book and do the homework. The homework assignments and quizzes for the course are going to start right away, so you need to start reading the book and doing the homework as soon as you possibly can. Here's the title of the book: Introductory Statistics for the Behavioral and Health Sciences. This book will be provided to you without charge on Blackboard. Now, the quizzes and exams for this course are going to be based on the homework problems. In fact, most problems on the quizzes and exams will be identical or nearly identical to the homework exercises. So although you don't have to turn in your homework, you do need to do your homework if you want to pass the class. So again, if you want to succeed in this class, the first thing you have to do is read the textbook. And this is something you do not want to procrastinate, especially for a summer course, because it's really fast-paced. The second thing you have to do is do the homework exercises. As I've mentioned before, the questions in the quizzes and the exams are going to be identical or nearly identical to the homework exercises that you can find in each one of your chapters. Also, all answers to these exercises are going to be towards the end of each chapter. The third thing you have to do is come to class, and by that I mean you must be watching these lectures because these lectures are going to complement what you already learned in your textbook and your homework exercises. And the fourth thing is that if you are having difficulty with material, you can do a couple of things. One, you can use the resources that are cited in your book. You can access some of YouTube resources like the Math Center, or of course, you can ask me or your TA, who are your biggest resources in this class. I am here to help you. If you're having difficulty with the material, all you have to do is email me with your question. Okay, so now let's go over some of the most important points in the syllabus. There are 2 things you need for this class. The first one is your textbook, which I have already mentioned that is going to be free and available to you on Blackboard. The second thing is that you will need a simple calculator. And by simple calculator, I'm referring to a calculator that can only do the simple functions of addition, subtraction, multiplication, and division. You cannot use your cell phone calculator, and you cannot use any Texas Instrument calculator that has the ability to graph or store information. For this class, you're going to have 10 quizzes in total. Out of these 10 quizzes, the lowest 2 quiz scores are going to be dropped. All quizzes are going to be completed on Blackboard, and you will have approximately 30 minutes to complete each quiz. All quiz questions are closely based on the homework problem. So as I have already mentioned, a lot of the quiz questions are going to be identical or nearly identical to the homework questions. This is why if you do your homework, you're going to succeed in this class because you will be able to perform much better in the quizzes. Now, this is also very important. There are no makeup quizzes. If you miss a quiz, you will not have the opportunity to take the quiz at any other time. And this will just become one of the 2 quizzes that you will end up dropping. There are 3 exams in the course, 2 midterms and a final exam. There are no makeups for these exams unless you have notified me beforehand. So if you have to miss a midterm or a final, email me beforehand and we'll arrange a makeup. Now, please be aware that you will have to provide documentation for why you have to miss an exam. And here's the breakdown of how your final grade is going to be computed. Your best 8 quizzes are going to count for 40% of your final grade, while your first midterm, second midterm, and the final exam are going to count for 20% of your grade. All quizzes and exams will be curved based on how the class does on any quiz or exam. Here's how the curve is calculated. I take the top 10% of grades the students earn on a quiz and average them. Then I calculate other students' grades based on that. So for example, if the top 10% on a quiz have an average number of 10 correct on a quiz and you get a correct, then your curve grade will be an 80. For a more detailed explanation of how the curve works, please refer to your syllabus. Almost every section in your book has homework exercises assigned to it. The answers for all homework exercises are at the end of the chapter, so whenever you finish completing a homework problem, you can go to the end of the chapter and check if you were correct. You do not submit the homework. This is only a study tool for your own benefit. As I mentioned before, questions in the quizzes and the exams will look very similar to those homework problems, so if you do know how to do those homework problems, you're more than likely going to do well in the quizzes and the exams. So doing the homework is probably one of the most important things you can do for yourself in this course. There are 5 extra credit opportunities for this class, and each extra credit exercise has 2 deadlines associated with it. You need to make sure that you complete these extra credit exercises by the deadline if you want to get credit. Also, it is important to know that you have to complete the early extra credit assignments for you to be able to complete the later extra credit assignments. And what I'm trying to say with this is that if you do not complete extra credit 1, you will not be eligible to complete extra credit 2, 3, 4, and 5. So if you miss one extra credit assignment, you will not be able to complete anything that goes after deadline of that particular extra credit assignment. Now, all extra credit assignments will be submitted on Blackboard, and in Blackboard, you'll be able to find more detailed instructions about how to request numbers, how to do the exercises, and how to submit these extra credit assignments. All lectures will be posted on Blackboard and they will be organized through different folders. Inside each lecture folder, you're going to be able to see a couple of things. The first one is a link that will take you to a YouTube video of a pre-recorded lecture such as this one. You will also have access to the PowerPoint slides in case you would like to take notes while watching the videos or the lectures. And you will also have a class exercise or handout if there is a particular class exercise or handout to be completed for that specific class. Another thing you should know about the lectures is that you will have different instructors per lecture. So sometimes it's going to be me, but many times it's going to be a different statistical methods instructor from UTEP. Now, although you will have different instructors per lecture, the material that is covered by that professor would be the same material that I would have covered on my own. If you have any questions about this, please let me know. However, I will be sending an email that's going to explain a little bit more about how that's going to work.
I will have review sessions for every exam and I will have office hours every week. Both of them take place on Blackboard Collaborate Ultra. You can find the link on Blackboard. Now, the review sessions, please make sure you are aware of when the review sessions will be taking place. You can find those dates in your class calendar. Again, you can find it toward the end of the syllabus. I will also be having the office hours. During the office hours, You can come to me to ask any kinds of questions about the materials. This is a perfect time that if you're struggling with some kinds of problems or specific kind of concept, you can come to my office hours and ask me. My office hours are going to be on Tuesday from 1 p.m. to 2 p.m. Or if this time doesn't work for you, you can always arrange the time through emails to have a specific appointment for you.
Please make sure you read the syllabus for any additional important information that I might not have mentioned. Now, before I move on to cover some statistics material, I wanted to make two quick announcements. The first one is that if you are a CAS registered student, you need to make sure that you are in contact with CAS, that they know you're taking this course, and they send me a letter with any accommodations that you may need. The second announcement is that you really need to be familiarized with your class calendar. There's so many deadlines that are coming up, and it's very easy for you to miss one of those deadlines if you're not paying attention to how the course is progressing. So for example, this week we have 3 quizzes, we have 1 review session, and beginning next week you have your first midterm. So please again make sure that you review the class calendar and that you know what to expect for each one of the days. If you have any questions about any of the material that I have covered, please let me know. You can email me and I will respond to you as soon as possible. Now we're ready to talk about the subject of this course, statistics, and I will begin with a pretty basic question. What are statistics? The first statistics were developed in the Middle Ages by kings. In the Middle Ages, information was very hard to come by, so kings usually didn't have basic information about their kingdoms. For instance, most kings didn't know, even approximately, how many people live in their kingdom. So some kings began taking censuses to gather that information, to find out how many people live in their kingdoms, how many farms and businesses there were, how many cattle, horses, and sheep they had. In those days, kings referred to their kingdoms as states, and the numbers they gathered about their states, that is, their kingdoms, were called statistics. That's where the name came from. A statistic or statistic was a number that told you something important about a state. Nowadays, we use the term statistic more generally to refer to a number that describes any group of people, not just a state or kingdom. Statistics can also describe other groups, like groups of animals or groups of machine parts. But in this course, the statistics are all about groups of people. There are 2 kinds of statistics, descriptive statistics and inferential statistics, and I will explain what each one of these mean. A descriptive statistic is any number that tells us something about a group of people. One common statistic is the average. For instance, the average age of students in this class is probably about 21. The number is a descriptive statistic and tells us something about the group as a whole. Another common statistic is the percentage or proportion. For instance, the percentage of students in this course who are female may be around 75%. We could say the same thing by saying that the proportion is about 75%. Again, this number is a descriptive statistic and it tells us something about the group as a whole. Most of this course is about descriptive statistics and how to use them. There is another type of a statistic called inferential statistic. An inferential statistic is a number used in research to tell us whether the result of a study could have occurred by chance. I'm not going to talk much about inferential statistics today because it's a complicated topic. However, we will be studying inferential statistics during the last part of this class, and that's when you will come to understand them. Statistics tells us about variables within a certain group. Which leads us to a different topic. What are variables? So let's go ahead and talk about this. A variable is a characteristic that can differ from one person to the next. For example, height is a variable that can differ from one person to the next. For instance, Marisela is 5 feet 4 inches tall, but Alfred is 6 feet 2 inches tall. Other examples of variables are age, income, and ethnicity. Each person has their own value on a variable. For instance, Maria has a value of 5 feet 4 inches on the variable of height. Alfredo has a value of 6 feet 2 inches on that same variable. Here's a table of data showing the values of 4 people on 3 variables. Each row of the table is a different person: Sam, Mariana, Morgan, and Ricardo. Each column of the table is a different variable: height in inches, hair color, and number of pets. If we read the first row of the table, we can see that for the variable of height, Sam has a value of 67 inches. On the variable of hair color, Sam has a value of brown. And on the variable of number of pets, he has a value of 0, which means he doesn't have any pets. Each row of the table provides similar information about a different person. In statistics, we often use capital letters to represent the name of different variables. For instance, in this table, the capital letter X represents height, the capital letter Y represents hair color, and the capital letter W indicates the number of pets. Also, in statistics, we often use lowercase numbers to indicate the values of individuals on the variables. For instance, in this table, x1 equals 67. The letter 1 beside the x is called a subscript. The lowercase x with the subscript 1 represents the value of the first person, Sam, on the variable x, which is height. So x1 is equal to 67 because Sam's height is 67 inches. Similarly, y4 represents the value of the fourth person on the variable y. In other words, y4 is the value of Ricardo on the variable hair color. In this case, y4 is red because Ricardo's hair color is red. There are different types of variables. Some variables are categorical, or also known as nominal variables. These are variables for which different individuals fall into 2 or more distinct categories. For instance, nationality is a categorical variable. Individuals fall into many categories such as French, Mexican, American, and so on. Religion is another categorical variable. Individuals can fall into different categories: Catholic, Protestant, Jewish, and so on. When a variable is categorical, we can count the number of individuals that fall into each category. For instance, we might say that 35% of Americans are Catholic, 45% are Protestant, and 5% are Jewish. However, we can't average a categorical variable. It makes no sense to say we took a group of Catholics, Protestants, and Jewish and calculate the average religion. Another type of variable is called continuous. Sometimes these variables are called interval or dimensional variables. The values of a continuous variable are always numbers. That is, continuous variables are numeric. For instance, height is a continuous variable. If we have several people, their individual heights are their values. The values are numbers such as 60 inches, 63, and 72 inches, and so on. If a variable is continuous and we have 2 values for this variable, we can always find a third value that is in between them. So for instance, imagine we have 2 values of 60 inches and 62 inches. We can find a third value between them, 61 inches. Similarly, if we have 2 values of 60 and 61 inches, we can find a third value between them, 60.5 inches. And so it can go on forever, at least in theory. No matter how close 2 values are, there is always another value between them. Discrete variables are another kind of variable. They are also numeric. However, if a variable is discrete, the numbers are not continuous. The values are usually whole numbers with no possible fractions in between them. So for instance, if someone asks how many brothers and sisters you have, you can say 1, 2, 3, or more, but it makes no sense to say I have 1 and 1/3 brothers. Brothers come as individuals, not as fractions of individuals. So the values of a discrete variable are generally whole numbers without any fractions in between them. Ordinal variables are another type of numeric variable. Ordinal variables are simply orders or ranks: first, second, third, fourth, and so on. The word ordinal comes from the word order because an ordinal variable tells us the order of individuals on a variable. A last type of variables are called dichotomous. They are also known as binary variables. A dichotomous variable is a variable that has only two categories. For instance, being an international student is a dichotomous variable because it only has two possible categories. Yes, it is an international student, or no, it's not an international student. Another example is survival outcome. Either the person is dead or is alive. Dichotomous variables are very common in research and have some special properties. We will be discussing them quite a bit later in this course. So we have described what a variable is. We have also talked about that each person has their own values on a variable, and we talked about different types of variables. Finally, for today, I'd like to begin introducing you to statistics and how they can be interesting and useful. I will be using real data about the Titanic, the huge ship that sank in the North Atlantic in 1912, taking more than 800 people to the bottom of the ocean. The question we're going to examine is, what was the relationship between gender and survival on the Titanic? As we go through this example, I will be pointing out how a researcher would use statistics to approach this question. As you will see, there are 6 steps that the researcher would go through. Step 1. The first step the researcher takes is to identify the variables whose relationship is being examined. So we say the research question is, how was gender related to survival on the Titanic? What are the 2 variables involved in this research question? Remember, a variable is a characteristic that may vary. That is, it may be different from one person to the next. So in this example, what are the 2 variables? If you guess gender and survival, you are correct. One of the variables we're interested in is gender. We said a variable is a characteristic that can vary. That is, it can change from one person to another. Gender can be male for some people and female for others. Because gender has only 2 possible values, it is a dichotomous or binary variable. This table shows the situation on the Titanic. 466 of the passengers were female and 843 were male, for a total of 1,309 passengers. The numbers were not equal. About 1/3 of the passengers, that is about 35.6%, were females, and the other 2/3 were males. The other variable we're interested in is survival. This characteristic can also vary from one person to the next. Survival is also dichotomous. Some people died when the Titanic sank, others lived. This table shows that 809 people died. That's more than 60%. And what was the main reason so many people died? Well, certainly the iceberg was responsible for the ship sinking, but most of these people would have lived if the company that owned the Titanic had included enough lifeboats for everybody. So as a first step, the researcher has identified the 2 variables of interest, gender and survival. In the second step, the researcher has to decide what descriptive statistics will be used to examine the relationship between these 2 variables. In this case, the descriptive statistic that will be used is the percentage of passengers who survived. The researcher will calculate the percentage of males who survived, then calculate the percentage of females who survived, and then compare the 2 percentages. The third step is to make a prediction about what we will find when we compare the 2 percentages. What do you predict we will find when we compare the percentage of males who died and the percentage of females who died? Go ahead and take a second. I personally think that males were less likely to survive. And why would you predict that? Well, we know that women and children were allowed to go into the lifeboats, but there was not enough room left for the men. We shall see what the numbers show. Here are the actual numbers. As you can see, among females, the survival rate was 72.7%. That is, 339 lived, but 127 died. For men, the survival rate was only 19.1%. Only 161 lived and the rest died. So if you were a male, your chance of surviving were much lower than if you were a female. And now we come to the next step. We know what the numbers are and what they tell us, but what kind of graph can we use to actually show the numbers? One picture is worth 8,000 words. In this case, we will be using a bar graph to show the comparison between males and females. This bar graph compares males and females and shows the same numbers we already know about. The bar on the left shows a survival rate of more than 70% for females. The short, pathetic bar on the right shows a survival rate of almost 20% for males. A graph really allows us to see the comparison quickly, easily, and clearly. For step 5, a researcher would calculate an inferential statistic. As I said before, inferential statistics come later in the course, and I'm not going to spend time explaining them right now. But if you put it very simply, the researcher has found that the survival rates were different for males and females on the Titanic. But the question is this: did males and females really have about the same chance of surviving? And did females do better just by luck of the draw or pure chance? Or instead, was something really going on here more than chance? Was there some other reason than pure luck that females were more likely to survive? In the case of the Titanic, we're comparing two percentages, the percentage of males who survive and the percentage of females. And when we compare two percentages, the inferential statistic that we use is called chi-square. Even though I'm telling you this, at this point, I don't expect you to understand what chi-square is. This table is showing us a value for the chi-square of 365.887. Take my word when I say that this is a very big chi-square. A big chi-square means that the difference in survival rates was unlikely to be due to luck of the draw or just chance. Now we come to the sixth and final step. The researcher knows that chi-square is very large, and therefore the probability is very low that the difference in survival rates was due to chance. But exactly how low is the probability? The researcher can calculate this probability. It's called a p-value. So here's the same table we just looked at. Here is the same huge chi-square of 365.887, and next to it on the right is the exact probability that the difference in survival rates was due to chance. As you can see, p is 0.000. That is, the probability is practically zero that the difference in survival rates was due to chance. There was a reason why males and females survive at different rates, and students in this class have offered some good ideas about what that reason was. So to review, here are the 6 steps the researcher went through. The first step was to identify the variables. In this case, they were gender and survival. The second step was to identify the descriptive statistic that will be used. In this case, we were comparing percentages, the percentage of males who survived with the percentage of females who survived. The third step was to make a prediction. Students predicted that women would have higher chance of survival, and the numbers indicate this prediction was correct. In the fourth step, we created a graph of the results. This allowed us to compare the survival rates very easily. For the fifth step, we calculated an inferential statistic. In this case, the inferential statistic was a chi-square. For the sixth step, we looked at a p-value. The p-value was low, meaning that the probability was very low that the difference between males and females in survival rates occurred by chance. So this is an introduction to the steps of analyzing data statistically in research. You probably didn't follow everything that I say, but I don't expect you to. At this point, I'm just sort of familiarizing you with the process, giving you a taste of what you will be studying throughout the course. If there are any questions, please make sure you reach out to me through email, and I'll see you next time on our next lecture.